Right now the job is completed, and all the errors all the errors and warnings that were causing trouble in simulation are removed. Let's go to the results module, and which is actually a visualization module, and let's go to see what's going on here. So uh, let's go back and launch it from here. So there is an exaggeration here, and this exaggeration is because of the scale factor. So I'll go to options, common, and in the scale factor you can see I mentioned that I only consider 10 repetitions, which is a very small value, and in that case you should see the deformation is very smaller here. So it's not a big deal. Let's look at the plastic strain here, and we observe here the plastic strain is very smaller. It's very smaller, and uh, in order to visualize it, we will change the magnitude here. However, for stresses, let's look at here, and let's go to option and common and change this to features angle here, and let's convert this to um, continuous. Click on apply. Instead of if we consider line, we can consider line as well. We can consider blended, but let's just do it by default, whatever it is, and let's run the simulation. What's going on here? Brilliant. You can see here we are seeing the repetitions for the 10 passes are visualized here. So there are only 10 passes that we are seeing here. And if you want to consider more passes, right? I think I have included this amplitude in this course somewhere in the previous videos. So you should find it here, and if it is not present in this contents, which I think it's not possible because I have done this included in this course and I remember that. So let me check which amplitude, which code we used here. It is in these modules. I think I missed how to discuss this tool and how to discuss this tool. So I'm going to do that again. I'm going to demonstrate this as well here. Anyways, let me find code here. This is for getting the active and inactive rutting depth, which I will demonstrate, and this is the code for generating input for tire passes, and I mentioned this in detail. Let me close the ODB, it's causing problem, and go back to the modeling environment here. And for modeling environment, for the load modules here, for the repetitive loading, I mentioned that if you have this code which I used here, a code for generating amplitude for each tire pass of the predefined location. So in the previous videos I have discussed this code in a very brief manner, and I remember in the videos I have included these comments as well. So it's not a difficult thing to consider here. And also I have discussed the location of the distance for the wheel starting and ending points, and it is in this module 3. So you can check this as well. Now I also discussed this nonlinear elasticity and plasticity models in one of my previous lecture series in this course for the soil model. So I did this in detail. So yeah, this is completed, and let me do this practice as a lab pour. That is only for considering how to use Python for automation, right? And for using it, I will use this this input file in the current directory, which is in lab 3, sorry. So I will take this input file and I'll paste it here, and let me show you something very important which you should consider when you are doing automation. So let's just go to the lecture series here, and in the lecture series you should find here this section which I am discussing right now. This post-processing techniques I will discuss as well, the visualization of stress, strain and deformation, and the interpretation of results. I will discuss this as well. So I did this one running full simulation in ABAQUS. It is covered in lab 3, right? This is also covered in lab 3 here. So this whole stuff is actually lab 3. So you can see here as well. I discussed all these in the previous videos. Now the analyzing results section will also be discussed, and then I have a separate special section for this automating pavement analysis workflow using Python, and creating batch scripts for repetitive analysis with Python. So these two are very important. I have some specific rules for this section. So let me introduce the visualization techniques. Once you have the results module, you can take the input file, was output file, and you can click on the exterior edges. Then after that, when you look at here, you can switch between creep, strain and deformations and stresses and displacement and all those steps here. So it's just an overview of the power of using Python, right? That how I did these input cycles identification using Python, and then I used that data into my ABAQUS file, and I simulated this. So now if you look at the results, you can go to the field output request results, and in the field output request results you will find out integration point. So just go to unique nodal and select any nearby node. Let's suppose I select this one. I will look at here and just plot displacement. Y2 is the direction of rutting, so I will plot it. Since these are 10 passes, so which is a very smaller number, and you will not notice this declination, but yeah, we got some smaller portion of permanent rutting because these are only 10 cycle and it is increasing here. So it's another thing that I'm going to discuss with the code, and that code is actually present here. If we, I'm sorry, if we go back to the previous lectures, in these lectures I have covered this portion. I think it's somewhere here. No, not in this one. It was in module 3. I remember it was in module 3. So this is the code which actually shows us the rutting depth, and I have demonstrated this in brief. So I will try to visualize these 10 cycles, that how we can get the rutting depth by doing automation for each successive tire pass, and then check what's going on here. So this is another thing that I am going to discuss in the coming video.